Hello, my name is Brankica Supica, and this is Differentiating Problem-Based and Project-Based Learning for DL 5103 Instructional Models for Digital Learning. Today we're going to discuss what are some of the differences and similarities between project-based learning and problem-based learning. Today I will be comparing those two different learning methods with the opportunity to understand the scientific method. This is following Illinois State Goal number 11, which talks about understanding the process of scientific inquiry and technological design to investigate questions, conduct experiments, and solve problems. First off, we're going to look at project-based learning using the scientific method. Using project-based learning is a very common activity in science classes, seeing as though labs are a great way to bring project-based learning into the classroom. The lab that I did in my class is called Following the Bouncy Ball. Students will be testing the height of different sorts of bouncing balls. They will be using a yardstick to measure the height of the different balls that have been dropped. After dropping the same ball, which could be a tennis ball, a golf ball, a ping pong ball, or a regular rubber bouncing ball, the students will drop the ball 5 times and take the average of those 5 trials. They still continue to use the steps of the scientific method. The students did pose a question, they did do research, they formed a hypothesis based off of their research, they tested their hypothesis, analyzed the data, and then concluded what they learned from it. Once the students have done all of the different steps, they are responsible for writing up a lab that was based off of using the 6 steps of the scientific method. Looking at problem-based learning with the use of the scientific method does take a little bit of creative aspects. Many students don't find reading directly from a book very interesting, and lecturing the students about the topic is not as effective as it could be. So what I used to make the students more aware of the scientific method with problem-based learning was using Simpsons scenarios. Using a great website called biologycorner.com, they created a bunch of different scenarios with the different characters from the classic cartoon The Simpsons. The different characters are performing different sorts of scientific experiments. Once again, all of the experiments that these characters are involved with involve using the steps of the scientific method. The students also get a chance to learn about independent and dependent variables, along with understanding what a control group is and how many different trials the cartoon characters did. BiologyCorner.com has created a variety of different scientific experiments that involve the characters from the TV show The Simpsons. Through these different example scenarios, the students are using the scientific method, understanding independent and dependent variables, and using their knowledge about control groups and trials to differentiate those different aspects. There are plenty of examples on the website, but the one that I'm going to show you today involves Smithers, Mr. Burns' assistant. Smithers thinks that a special juice will increase the productivity of his workers. He creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of papers each group has made. Group A made 1,587, while Group B made 2,113. Based off of this scenario, the students are going to answer 5 different questions about that situation. They will understand and try to identify what is the control group in Smithers' experiment, which one is the independent and which one is the dependent variable, what would conclusions state if they were Smithers, and how could they improve Smithers' experiment. To check out more scenarios, visit biologycorner.com to see what else is available. Now we're going to compare the project-based and problem-based learning strategies with the use of the scientific method. There are many commonalities that we can see that the 2 different learning methods have in common. one of the first things we see is that the goals that we are trying to achieve are going to remain the same. Through problem-based learning or through project-based learning, the intended outcome is for the students to understand and be able to manipulate the scientific method. Students will also be presented with the same information of the scientific method and the steps, but they're going to use it in a variety of different ways. Lastly, they will be applying the steps in actuality when they do the labs, but when they work on different problem-based scenarios like The Simpsons, they're actually using the theoretical knowledge that they have learned. Even though there are a lot of commonalities between project-based learning and problem-based learning, there are still a variety of differences. With project-based learning, the students are given a chance to do more analyzation of their findings because they are the ones in control. Since they are conducting the experiment, they are able to manipulate the results and analyze them more so than they would with someone else's errors. The other difference is that they have the opportunity to be actively engaged in a real-life experiment. The more hands-on students are allowed to get, the more learning and understanding they gain from it. With problem-based learning, it doesn't give the students the opportunity to get as hands-on as they could be. They don't get to manipulate any of the experiments in the scenarios because they've already been conducted for them. Also, the students have to activate their prior knowledge in order to successfully understand the scenarios. They are working with what they know in order to help the Simpsons characters figure out what is an independent variable, what is a dependent variable, and the different steps of the scientific method. Do I have a personal preference, you ask? Well, yes, I do. I would say that project-based learning is one of the more beneficial ones for a student in my classroom. The students are able to remain actively engaged because with science labs, they better understand what is going on in class and what difference one project has to another, and so forth and so on. It also heightens their level of interest. If they get to be a part of the learning, they'll want to be part of the learning. Students are willing to do more. They want to go further. They want to test out more opportunities in the classroom to see what they can learn. And it also is a great chance for group interaction. The students get a chance to work with one another and understand the benefits of working with someone and the struggles as well. Lastly, the hands-on learning. I can't emphasize that enough. The more opportunities the students have to get their hands on something, the better they will remember it and learn from. Beckett and Miller say that project-based learning aims for the reconstruction of experiences through interactive process with one's environment. Learning is viewed as the outcome for the learner's experience. The teacher's task is to guide, direct, and evaluate these experiences. And that's exactly what I try to do in my science classroom. This excerpt was taken from Project-Based Second and Foreign Language Education, Past, Present, and Future. Thank you so much for listening to my presentation about the differences and similarities between project-based learning and problem-based learning.